section number 46 is entitled Solving Systems of Equations Using the Elimination Technique. And for basic algebra course, their equations will be linear equations. Now, when you have two lines, two linear equations, either they will be parallel and they will have 0 points of intersection, or they will be parallel and be the same line and they will have infinitely many points of intersection, or they will be non-parallel and they will cross at one point. They will have 1 point of intersection. So when I write the equation down of two lines, when I ask you to solve this system of equations, these two linear equations, I'm asking you to find the point of intersection. That either there will be 0 points of intersection, there will be 1 point of intersection, or there might be infinitely many points of intersection. There will never be 2 or 3 or 4 points of intersection. If you draw two straight lines, they cannot intersect in just 2 places, or 3 points, or 4 points. Once they intersect in more than 1 point, they have to be the same line. If I'm going to draw 2 lines and they intersect at that 1 point, well, they can look like that. But if they're both going to intersect in those 2 points, and they're straight lines, well, then the first line has to look like this. And you know what? So does the second line, which means they don't just cross at those 2 points. They cross here and here and here and everywhere on that line. Now, the instructions are to use elimination technique. Since this is x and this is x, if I were to subtract these two equations, the x's will be eliminated. X minus x is 0. Yeah, positive 2y is just 2y, and positive y is just y. If you have 2y and you take away y or 1y, you're left with y. And 4 take away 2 is 2. So we have the y value of where they intersect. Now we pick one of those 2 equations on top and we solve for x. And say the second one. The second one says that when you add x and y, you get 2. But y is 2. What number, when you add 2 to it, gives you 2? 0. So the answer is, the solution is x, comma, y. The 2 lines do intersect in one place, 0, 2. Now, suppose you have 3x plus 2y is equal to 7, and negative 2x minus 2y is equal to 4. Now, let's just talk about something. Back to the first column. Since this and this were exactly the same, when you subtract, they disappear. Now, if you have 2 numbers like 7 and negative 7, other than the sign, they're the same number. You add to get 0. If you have negative 3 and positive 3, you add to get 0. But if you have the same thing, like negative 8 and negative 8, you subtract to get 0. Most students would know that x take away x is 0. And you'll never hear them say, but of course x has to be positive. X can't be negative. Then when they come to a problem like this, it's brutal for them. They say, oh, well, you have to change this and change that. And in addition, if the signs are different, you subtract, keep the sign of the larger number. X is now known to be -8. You have one number and you're taking away the same number, well, you get 0. Of course, I doubt you'd have trouble if they were if they were the same positive number. You would subtract to get 0. If the signs are different, you add. If only the same number but different signs, you add. This is plus 2y, this is minus 2y. We're going to add them, and then the y's will add up to 0. That is, they cancel out. 3 plus -2 is 1x. This we rig to cancel out, and remember we are adding. 7 plus 4 is 11. So we now know x. Let's go and find y. We know that 3x's plus 2y's is 7, the first equation. Well, 3x's, if x is 11, well, that's 33. 33 plus 2y is 7. Take away 33 from both sides, and you'll conclude that 2y equals -26. So y is -13. And the solution will be x, which is 11, comma y. 11, comma -13. Those two lines intersect at 11, -13. But other than the signs, you won't always have the number in front of x's or the numbers in front of y's to be the same. Sometimes they'll be completely different. For example, if you have 3x plus 4y is equal to 7, and say 2x minus 7y is equal to 5. The numbers in front of x's are 3 and 2. They're not the same. The numbers in front of y are 4 and 7. They're not the same. Then we can multiply one or both of the equations by numbers other than 0, and they'll become the same. Let's try to eliminate the number in front of x's. The first common multiple between 3 and 2 is 6. So let's try to get the numbers in front of x's to be 6. Well, if you have 3, you have to multiply by 2 to get 6. So multiply the whole first equation by 2. I'll get 6x plus, multiply this by 2, 8y equals, multiply by 2, 14. And to get 6x or -6x in front of x in the second equation, I'll just multiply by 3. When I multiply that by 3, I get 6x minus. When I multiply that by 3, I get 21y. And when I multiply this by 3, I get 15. Now, since these are exactly the same, I subtract. 6x minus 6x is 0. Now, before we go on, if somebody asks you what's the answer, that is, what goes here, you should say, how do I know? I don't know. And the reason you're correct. The reason you should know is because if it's adding, the answer is 9. If it's subtraction, the answer is 5. If it's multiplication, it's 14. So I've really never seen division, but if it was division, the answer is 7/2. So you don't know the answer. Before you combine, you must know what the operation is. And I'm not asking much of you to not combine numbers unless you know the operation. And our operation is right there, subtraction. You have 8y, and you want to take away negative 21y. This is 29y. This is 29y. And on the right side, you get negative 1. The right side, you get negative 1. Actually, let me make one simple modification. That 5 should have been negative 5. And when I multiply it by 3, it will become negative 15. And when I subtract these two numbers, I will not get negative 1, but I will get 29. I'll get 29. Remember, you're supposed to subtract. 14 minus negative 15, 29. So 29 times y is 29. Y is 1. Now you go back to any equation that you like that has x in it. Any equation. The first equation, the second equation, the 15th equation, I don't care. You shouldn't go back to this equation nor that one. Why? It doesn't have x in it. It doesn't have an x in it. So I'll go back to their top left equation. 3x plus 4y is 7. But I know y is 1. 4 times 1 is 4. So 3x plus 4 is 7. I know what that must be. It's 3. 3 plus 4 is 7. Had nothing to do with that 3. Some number plus 4 is 7. That number is 3. 3x is 3. Say x is 1. 3 times 1 is 3. And then the solution will be x comma y. X comma y. 1 comma 1. If you were to draw these two lines, all I will assure you is that maybe one line goes this way and the other line goes that way. But I will assure you that they will cross at 1, 1. Do they have to look like the way I drew? Absolutely not. One line could have gone this way, the other line could have gone that way. But they, nonetheless, they cross at 1, 1. That there is no question about. Possibly your teacher is one of many teachers who will tell you never subtract. Well, there is absolutely nothing wrong with subtracting. Suppose you have 3x plus 5y is 16 and 8x minus 10y is, say, 4. Now, the numbers in front of x's are different. They're 3 and 8. The numbers in front of y's are different. They're 5 and 10. Now, you need to ask yourself, which is easier to get to be the same numbers? Let me say more clearly. Is it easier to get the numbers in front of the x's to be the same, or the numbers in front of the y's to be the same? Now, the LCM of 3 and 8 is neither 3 nor 8. It's 24. That is, you would have to multiply the first equation by 8 and the second equation by 3. Okay. Now, the LCM of 5 and 10 is one of those two numbers. It happens to be 10. So you wouldn't have to do anything to the second equation that sounds easier to me. You have to multiply the first equation by 2, because 5 times 2 is 10. And 2 times 3x. So basically you're doing it. 2 times 3x plus 5y is equal to 2 times 16. You get 6x plus 10y. I'll put that up here. 6x plus 10y is equal to 2 times 16, or 32. In the second equation, I don't do anything to it. You want to write something, say you're timesing it by 1. You have 8x minus 10y is equal to 4. Okay. We are going to add these, because these numbers differ by just the sign. So when you add them, the y's will cancel out. 6x plus 8x is 14x's. Just canceled out, and we are adding, so we get 36 over here. So x is equal to 36 over 14, which is 18 over 7. I divided top and bottom by 2. This was a little bit easier than dealing with the numbers in front of x's, because I didn't have to do anything to the second equation. Okay, so we have x, and we go back to an equation that has y's. Say the first one, 3x plus 5y is 16. I know what x is. It's 18 over 7 plus 5y. Now, okay, equals 16. Now, this is 54 over 7 plus 5y. Now, you should anticipate bringing that to the other side. So you'd love to have as subtracting. That is, you're going to have to do 16 minus 54 over 7. Well, before you can do subtraction, you have to have the same denominator. So you want to write 16 with a 7 on the bottom. What goes on top? 7 times 16. 70 and 42 is 112. So this is 112 over 7. So you take away 54 over 7 on the left side, and you take away 54 over 7 on the right side. On the left side, that cancels out, so you just have 5y. I'll put that up here. And on the right side, you're subtracting, and we rigged it. The denominators are the same. You subtract the numerators. 112 minus 54, I think is 58. No, I'm sure it's 58. Okay. Now, you need to have some smoothness. You need to have some techniques behind you. On the left side, it's very, very favorable to divide by 5. And then you get y. Nice and smoothly. The right side, I don't want to divide by 5. There's an alternative to dividing by 5. 5 is 5 over 1. Instead of dividing by 5 over 1, you could multiply by the reciprocal. 58 times 1 is 58. 7 times 5 is 35. And now we have the solution. X is 18 over 7. And y is 58 over 35. And there's the answer. So, I'm going to do this problem all over again. Because there is one way we could have made this a little bit easier. When I look at the second equation, notice that all these numbers are even. If I were to divide by 2, I would get 4x minus 5y equals 2. And then the numbers in front of y would be the same. 3x plus 5y is 16. I just get smaller numbers. And I add. Why do I add? Because when I add those, I get 0. So it's 3x plus 4x is 7x. 16 plus 2 is 18. Divide by 7, divide by 7. I get x is equal to 18 over 7. Just like I got before. 18 over 7. And then everything else would be the same. I'll just write down the first line. So 3 times x plus 5y is 16. And continue just like I did in the first way I solved this. So don't be afraid of dividing. Sometimes you can divide. You don't only have to multiply. The good thing about dividing is when you divide, you get smaller numbers. Who wants to deal with big numbers? Small numbers, we're better at. You know what 2 plus 3 is. If you don't know what 2,312,078,412,328 equals. Do a couple more. Suppose you have that 5x minus 2y is equal to 4, and that 10x minus 4y is equal to the number 7. Now, you might notice that you can divide by 2. Well, actually you can't. I don't know what 7 over 2 is. So, the first common multiple of 5 and 10 is 10. That is, and 10 is one of these numbers. That is, I would only have to deal with the first equation, change the first equation. And if you looked at 2 and 4, the first common multiple is 4. I already have a 4 there. Only have to change the first equation. So, which one we change now? Let me say it correctly. Getting the x's to be the same or getting the y's to be the same numbers in front will be the same level of difficulty. We would have to modify only one of the equations. So let's get the x's to be the same. 5 times 2 is 10. So when I double the first equation, I get this. And I don't do anything to the second equation because I already have my 10x. Now please remember when you subtract the same things, you get 0. 10x minus 10x is 0. And negative 4y minus negative 4y is 0. Not only did the x's get eliminated, so did the y's. But when I subtract the right side, I get 1. 0 doesn't equal 1. There is no solution. The two lines are parallel. And it kind of makes sense. When I look over here, I have on one hand that equals 8, and on the other hand, the same exact left side equals 7. How can this, they're the same, I can call it one thing, how can it equal both 8 and 7? I know one thing. If this is equal to, say, a triangle, and it equals to a circle, if that's true, then the triangle equals a circle. That is, if this number equals that number and that number, then these two numbers must be equal. If 10x minus 4y equals 7 and it equals 8, then 7 and 8 must be equal. But that's nonsense. That's why there's no solution. And we talked about it, that is, no point of intersection. What does that mean? Lines are parallel and don't intersect. The lines are parallel. Which lines? These two lines. 5x minus 2y equals 4, and 10x minus 2y equals 7. They're parallel. The two lines are parallel and don't intersect. Okay. Let's do one more. Suppose you have 3x minus 2y equals 7 and negative 6x plus 4y is equal to negative 14. Now before we go on, as in the last problem, if you get 0 is equal to something other than 0, or 7 is equal to 8, or 11 is equal to 13, there's no solution. The lines are parallel. Okay? Whenever you get something like that, you're done. No solution, but no points of intersection. The lines are parallel. Okay, 3 and 6, 2 and 4. Well, if I double the first equation, the x's will be the same. Up to the sign. I don't care about the signs. If I double the first equation, I'll have 6x minus 4y equals 14. And if I do nothing to the second equation, I will have this. And since they just differ by signs, I add. When you add these two, they cancel out. When you add to 0. When you add those two, they cancel out to 0. The left side is 0. And when you add the right side, 14 plus negative 14 is also 0. The two, since this is true, 0 equals 0 or 9 equals 9, the two lines are parallel, but intersect. But they intersect. Now, the question has always been, where do they intersect? Okay, when they say solve this system of equations, they're asking, where do they intersect? And the solution is the two lines intersect everywhere. A lot of students stop right here. They intersect everywhere. Well, that's not true. Maybe this is the first line and this here is the second line. Now, come on. They didn't intersect there. And that's plotted everywhere. They didn't intersect here, nor here, nor here. They intersected everywhere on the line. They intersect everywhere on the line, and you pick one of the two equations. 3x minus 2y equals 7. Where do the two lines intersect? Oh, they intersect everywhere on this line. And that would be the answer. That is the answer. Okay, that completes the section solving system of equations using the elimination technique. Next section, we're going to solve some more system of linear equations, but we're going to use a different technique, the technique called substitution.